Hello, welcome back to Cracking the Cryptic, where we're going to take a look at another different sort of puzzle today. This one has come in to our email from Joseph, and it's called a Samurain puzzle. Now, I've never heard of this puzzle before, never done one in my life. Joseph says they're fun. I think these also herald from Japan. And how do they work? You can see it looks a bit like a crossword, and looking at the rules, I think it has sort of similarities with Sudoku and with Kukuru. So the rules work, each row and column you can see it has got an extra clue, and these clues are the sum of the entries in the row or column. So in this row, this 6,992 is the sum of this number and this number. Similarly in row 1, this 111 is the sum of these 4 different entries. And there's only one more rule besides that, which is that you cannot repeat a number in a row or a column. So just like Sudoku, and you can't use 0. So you're choosing from Sudoku numbers, but you can't repeat them. And that's all there is to it. And apparently using those restraints, we can fill the grid uniquely. And that's our task. Now if you want to try the puzzle, click on the link under the video. That'll take you to our software, and you can have a go. So how do we do this? Well, I don't know. My eyes are drawn to the big numbers, I guess. So we've got this huge number in row 2, and that is combined of a single-digit number and a huge number. So we're going to be able to write some digits in here, aren't we? We're going to be able to write at least that many in. Now this could be a... Well, actually, interestingly, this number cannot be a 5, because that would repeat the 5 in the row. So the only possibility for that number is a 4, which means these two numbers effectively have to add to 16, because we've got 325,840 basically in the grid. We need another 16 to make the total up to this number, so we're going to be able to put in 7 and 9. 16 in 2 digits, if you can't repeat them, can only be done with 7 and 9. Now, what next? Well, if you look down here, we've got 2,000. We've got a 2-digit number and a 1-digit number, and this is a 2,800 number. So we're going to be able to write in a 2 here, and this number therefore will have to be 7 or 8. But it can't be 7, because if we put a 7 here, this square will be a 9. But I want to put the 9 in this. In the sort of tens digit in order to give me a 90 number to add on to the 2007. It just, yeah, it's not going to work, is it? This number is going to have to be an 8. That's got to be the case. Now, looking at this row now, just because it's taken I've got 6,000 here. So this is obviously, I mean, in theory, could this be a 5? I don't think it can be, because this number here would then have to be a number bigger than 990, which would repeat a 9. So that's a 6. I don't know really about these 2 digits. Okay. Now this is 10,000 here, so that's got to be a 9, because we're only adding a 3-digit number to it. That square is a little bit restricted by this 1200 total, but probably not enough to be the next place to look. This 277, that's going to have to be a 2, because I can't make these 3 digits add up to enough that this could possibly be a 1. And another massive digit, so we're going to be able to put in a few numbers along here. Now we can't have a 1 here, because that would repeat the 1, so this is a 2. These 2 digits have got to add up to 8, therefore, without repeating a digit. So we can't have 1 7, we can't have 2 6. So this must be 3 and 5. Oh, and now if we look at this column again, we've only got 2 entries in this column. So the units digit in the total is a 1. So if this is a 3 or a 5, this must be an 8 or a 6. Now, can we use that over? Well, actually, on this column, we've got a 2. That's going to be a 2, hasn't it? Because it's a 2000 number. Therefore, and we can only add a maximum of a number just over 100 to that. So the options for this square are 3 or 4. Well, not 4, because we've got to add a number bigger than 90 to it. So in fact, that is a 3. Therefore, this can't be a 6, can it? Because if this is a 6, it's impossible to make this bit as even up to 400. So we can never get to a number that's 168 bigger than 10,000. That has to be an 8. Therefore, this is a 3 and this is a 5. Which means this must be a 7, and 1, 2, 1 with the remaining digits. So that has to be 9, doesn't it? Oops, it won't let me put it in, but I think it has to be a 9. Okay, so where should we look next? I don't think we're going to be able to get too much more from this column in the first instance, because there's too many options for how we're going to make the 91 total that we're left with. We've obviously got the 2,800 in, but we need more. Is that interesting? In this total here, we've got to make a number ending in a 3, and we've got an 8 here. So these two digits are going to have to add up to 5, or obviously 15. But they can't add up to 15 because we've already got an 8 and a 9 in the column. So they've got to add up to 5 without using a 2. So I think that means they have to be 1 and 4. And that might be interesting here. So if this is a 1 or a 4, well, no, I still think there are a few options for this square, so maybe that isn't the place to look next. Sorry, we should have looked here. 5, 6, 1 with a 7 there, so that's got to be a 4 in order to make the units total work. And that seems to be the way we have to do this puzzle. It's a bit iterative, isn't it? That's got to be a 1 because this square is a 1, 4, 6. So that square, this square here can be 5, 6, can't be 7, or 8. That's the only options for this square. So this square can be 1 or a 2 in theory. But this is a 2, that breaks. If this is a 2, the minimum I could make this would be 3, 5, 4. And that would put a 0 into this square. Well, we can't have a 0 in the column, so this cannot be a 2. This must be a 1. And this just doesn't work, does it now? Well, it works with a 6, but it doesn't work with an 8, and it doesn't work with a 5. And the reason for that is that we need effectively these to total 15 or 5. So 15 is just impossible. If I take the 5 as the option, that would mean I have to put a 0 or a 10 in here. 8 would require a 7 here. That's not going to work. So this has to be 6, and this has to be 9. 2, 6. These two cells have to sum up to 11, therefore, without using 2, 9, without using 5, 6. So this is either 3, 8 or 4, 7. And, well, shall I put that in? I might as well, just to remind me. Maybe we can look here. So we've got now 60. these two cells have got to sum up to 8 without using 2, 6 or 3, 5 again. So this has got to be 1, 7 this time. Again, I don't think we can see which way round that goes. Ah, we can though, because look, this total is 857, so there's no way this can be a 1 because we're only adding 2-digit numbers to it. So that must be a 7. This is a 1. Not 1 is not particularly helpful. So we've basically now got 780, well 782. That's one way of viewing this column, isn't it? We've got 782 into it. So we've got to make these other digits add up to the balance. And I guess if this is a 2, these two digits have to add up to 5 or 15. So they could be 6 and 9, or they could be 1 and 4. I wonder if that is worth notating. So that would be, in that case, this could be, oops, no, undo that. 1 and 6 are here, so this could be a 4 or a 9, and this could be a 6 or a 1. Now if this is a 4 or a 9, it's got to pair up with this digit to give a 2. I'm just wondering if we're going to be able to, yes we can, look, this can't be an 8. Which, if this is a 4, this would need to be an 8 in order to give us a 2 in this digit. So this, I think, must be a 9. And therefore this can be a 3, and that does work. Now if this is a 9, that means this is a 6. Still sort of working, isn't it? So now, I suppose we're getting closer. We've still got to, we can now hone in on the value of these two digits. So we've got 88 plus 9, 88 is 97. So we've got 797. We need these two digits to add up to 6 without using a 2. So they have to be 1 and 5. And again, look at this. This square can't be a 1. I want to make that too small. So that must be 5 and 1 like that, I think. We've got 580. And we need another 137 using the remaining digits here. So, yeah, okay, there's a few ways that could go, I think. Just wondering about the units digit here. We can obviously limit the value of this square somewhat, because we know this square is forced to either be 3, 4, 7 or 8, and we have a 1 here. And we're looking for a 4 overall. So this cannot be a 3, because that would force us to put a 0 or a 10 in here. Interesting, isn't it? So that's not... So this would, 4 would put a 9 in here. Put a 6 in here. That's... And 8, 9 would put a 5, so 8 is not possible. Ah, so this becomes 4, 7, and that means that becomes 4, 7 over on the right-hand side. So, what next? Well, this square needs to be... It can't be a very small number, but I'm wondering whether that is the easiest place to look next. 100. 2,390 here in this column. So I'm still looking for 77 in these squares. So this has to be, this can't be a 5, look, so this has to be a 6 or a 7, just looking at the Sudoku implications. 77. So if this was a 7, that would mean the other 3 squares would have to add up to 7 as well. They'd have to be 1, 2 and 4, which would put a 1 here, but that does look possible, annoyingly. So maybe that's not the place to look. 3. Guess, can we limit the value of that square? I suppose we can a little bit. If this is a 4, this has to be a very big number. Ah, that doesn't work. I can't put a 9 in this square because of the 9 here. So if this is an 8 and this is a 4, that gives me 1200, which means these digits here would have to give me 176, which is not possible given that we've got a 1 in this position. So this, in fact, is not a 4. That was quite difficult to see, for me anyway. So 7 now. So this looks like it's got to be a 6, I think, because it can't be a 5. Does the 6 help with this total along here? Yeah, it certainly limits the value of this square. But let's carry on just focusing here. We've now got 1, 3, 6. So these squares here have got to add up to 16. Again, that's not, I don't think that's brilliant in terms of restricting what we need to do. So what are the actual Sudoku options for this square? We've got 1, 4, 5, 7. I think those are all of the options for this square. Now, are any of those ruled out? Clearly 7 is ruled out because that would get far too close to this total. 1 is ruled out because that would be far too far away from the total. So is 2, 4, 6 possible? No, because 2, 4, 6 would require these 3 squares to add up to too many. They'd have to add up to 31. Absolutely impossible. So this is a 5. Okay. 2, 5, 6. So now these have to add up to 21, which is another way of saying these two have to add up to 12 without using 3, 9, without using 5, 7. So this is a 4 and an 8, and we have a 4 there, look. So that's 8, that's 4. Now we've got a 1 and a 4 in this column, which add up to 5. We need the units digit to add up to 4, so this must be a 9. Which means that's a 7, look, and that's a 9. Finally, we resolve that. And now we should be able to hone in on this summation here, because we've got 71, which plus 9 is 80, plus 64 is 144. So these have to add up to 7 without using 1, 6, and without using 3, 4. So these two squares are 2 and 5. This 1 here resolves that that's going to be a 4. Therefore, this has got to be a 5, I think, just because of the total here. This 4 resolves that 1 at the bottom. So we've got 7, and we need to get up to 14 in effect. So these two squares are going to have to add up to 7. We can't add up to 17 because it's already a 9. So this is either 2 and 5, which it can't be, or it's 4 and 3, which it can be. So I think that must be that way round. That gives us 9 in the unit digits here. We need 17, so that's got to be an 8. We're sort of closing in on the solution slowly. I'm not sure whether I like this puzzle. It's a weird one. This has got to be a 6. Is that right? It's either a 6 or a 7. It's a 7 in order to make the total work. So now we're in business looking at this column. We've got enough information to solve it. We've got 16, 2851. We need 2891, so that's a 4. So we've now got 90 in effect in those two digits. So we need the other digits to add up to 21. These two digits add up to 9. So these two digits have got to add up to 12 without using 5, 7, without using 4, 8, because we've already got those numbers here. So we must be using 3 and 9. and that must therefore be that way round. So now this total must be doable. Again, looking at the units digit, which we seem to have to do a lot here, that's going to have to be a 4. And we're just finishing off now. So we've got 59 here, 63. So we've got 963, and we need, so that's got to be a 7, 6, 9, and hopefully that's correct. So interesting puzzle. I'm not sure whether I liked it, as I say. I'm not sure whether I did it in any way efficiently. It felt just like a sort of scanning and iterative exercise, but let us know in the comments if you liked it. If you did, we can always find more, I'm sure. Thanks for watching. Back soon with another edition of Cracking the Cryptic.